Hi everyone, sequence of instructions. Thanks for joining me. I'm going to run through an easy exercise on LeetCode. This one's called reverse integer. So let's get started. The instructions here are to reverse digits of an integer. Pretty straightforward. The examples here are x, if it's 1, 2, 3, should return 3, 2, 1. If they give us a negative value, a negative 1, 2, 3, it should return negative 3, 2, 1. So we're not simply going to reverse all the characters in it. We're going to maintain its negativity. So the input is assumed to be a 32-bit signed integer. Your function should return 0 when the reverse integer overflows. Your function should return 0 when the reversed integer overflows. Got it? I won't subscribe. Okay, I'm going to do it in JavaScript. You'll notice here it wants us to return a number. That's important. Okay, so my first thought is to convert this input, which is a number, into a string so we can iterate through it character by character. So to do that, I'm going to declare a new variable called string x, and it's going to be empty string plus x. So this is going to coerce x to be a string, because JavaScript only likes concatenating strings. So let's use a string here. It's going to pretend that they're all strings. So this is going to give me, I believe we come here, coerce x to a string. So if x is 1, 2, 3, it'll be the string 1, 2, 3 now. We're going to want to store our, we're basically creating string buffer. So every character we get in our reverse string, let's say it's 3, 2, 1, or I'm sorry, the number is 1, 2, 3, we want it to become 3, 2, 1. So for every string that we get, we're going to iterate in reverse and store it into a buffer in the order that we encounter them in reverse. So this is going to be my string buffer. I'm going to call it retval. I'm going to instantiate it to an empty string. Okay, so now I'm going to do a for loop. For bar I equals 0. Spacing is important. We're going to loop through for as long as I is less than string x.length. Length and add 1. So this is like a normal for loop. But like I said, we're not going to be going from 0 to the length of the string. We're going to go in the reverse order. So we're going to start I at the length of the string minus 1, because the string is length 3. Our raise counter started at 0, so it would be 0, 1, 2, 3 would be nothing. It would be an overflow. So we want to start at the length minus 1, the index of the character we want. We're going to go for as long as I is greater than or equal to, greater than or equal to 0. And again, we're counting down, so we're going to decrement and then increment. Okay, so again, at this example I'm referring to, it should go at the length of the string x minus 1. So the length is 3. This is going to be the index at point 2. Go to point 1, we'll go to point 0. And we won't go to negative 1 because negative 1 is not greater than or equal to 0. Okay, so this looks good. So for each step I said we're going to add on to our buffer the character at the character at string location x's index of I. So when I is 2, we're going to look at what's the character at index 2 on string x. We're going to add it to our retval buffer, go on to the next one. Okay, and this will work, or should work, for the positive ones. They're returning though to the caveat here, where if it's negative, we want to keep the negative. So the first thing that jumped out at me is maybe to just check it off the bat if it is negative, if x is negative, and if it is, maybe start our buffer with a negative sign, and then make x positive. So to do that, we'll just do a quick condition. If x is less than 0, if our x is negative, we're going to start our retval buffer as a negative. And then, so that we don't hit the negative again, we're going to just set x equal to its absolute value. I typed that in a weird order. So x is going to become the absolute value of itself. So if it was negative 321, we're going to say, yep, rect_val is going to have a negative, and you're going to become regular 321. Okay, and then we just loop through like we normally did, and then we return it. However, there's two things we have to do. One of them is the return value should be a number. So whatever value this is, we're going to parse the integer and parse the value as an integer. So we know rect_val is going to be a string. We built a string. We want it to be returned as an integer. However, there's one final caveat, and that is this note. This input is assumed to be a 3-bit integer, signed integer. Your function should return 0 when the reverse integer overflows. So an overflow, this is a little complicated, but an overflow of a negative will become positive. And so basically, if we're gonna do one last thing, we're gonna overwrite rect_val to its thing, to the integer parse of itself, and we're gonna say, okay, if rect_val is how do I do this? It's greater than 0, but it would be greater than 0. So we'll say if x is less than 0 and rect_val is greater than 0, because remember we said if it started negative, it should remain negative. So we say, all right, well, if it started off negative and it's not negative anymore, we know that it overflowed. We're going to return 0. Otherwise, we just put it down here, or return rect_val. And this, I think, should work. First return 0 when the reverse integer overflows. This should be an indication of an overflow, I believe. I'm not positive on that, but I think it might work. My email is not verified. Wonderful. Alright, I'm going to cut this portion out, and I apologize. The growing pains of a new YouTube channel. But I'll cut this right back, and we'll see if it works. Okay, I verified my email address, and hopefully it lets us submit now. This looks different than it did before, so is there test cases or something? Run code? Run code too soon. Please rerun in a moment. That's strange. I just clicked it, so unclear. Let's just submit it. Let's just run through it one more time. I think this will work. So we're gonna get a number. We're gonna coerce x into a string. Maybe I should add some commas in here. We're going to store our reversed string into a buffer called rect_val, which in hindsight maybe shouldn't be called rect_val because we do some more manipulations to it before we return it, but it's fine. Here we want to store the negativity. I keep wanting to say polarity, but I'm not confident that's the word. Of our input. So if it is negative. So we do that by basically storing the negative value, or the negative indicator, the sign, and then working with the positive value of x. So at this step, x will be positive, so we don't have to worry about a trailing negative when we reverse it. We then loop through. Oh, see, here is a bug. Here is a bug yet. This, yeah, okay, this is good that we did this. So this is part of the process of programming, is you read through it and you realize maybe you had made a mistake. And the mistake I made, which maybe some of you watching this were noticing earlier than I did, but at this step, x could be negative. And so our string version of x could be negative. And if it is, it'll have a negative value when it's coerced. And so even though we set x to an absolute value here, we didn't overwrite our string value of x. And so looping through, this loop will have, or may have, a negative if x did. And so to get around this, we're going to do this check higher up. So we're going to do this up here. Whoa. Stop doing that. We're going to do this up here. So we're going to say, right off the bat, is x negative? Make it positive. Then we're going to store it. and at this step x will be positive. So right off the bat we get our ret val. We go, alright, is x negative? Make it positive. Then stringify it. This is a comment about what our function should do. I'm just going to remove it. Okay, so then we loop through in reverse order. So we're going to go from the largest magnitude down to the, we're going to go from the smallest magnitude to the largest and store them in reverse order into our string buffer here. So start at length -1. We're going to go until we hit 0, going down each time. We're storing, concatenating, plus equals, the character at index I of string x into our ret val. So, okay, now we're going to transform our ret val back into an integer. We're going to check, alright, when transformed back, did the negativity change? It did start negative. Okay, here's another problem. See, good thing we run through this. What did we say up here? At this step, x will be positive. So x is never going to be less than 0. What can we do? Well, we can store x. We can just make another variable for it. What should we call it? X original equals x. So if x original was negative and ret val is positive, we know that it overflowed. We're going to return 0, otherwise we return ret val. Good thing we ran through this. Maybe this works. Alright. That's all you gave me, huh? Alright, well, whatever. Let's submit it and see how we did. Trying to resubmit too soon. That's so weird because I don't remember submitting before, so strange. I guess I'll cut this part out if I have to. Wrong answer. Input was 1.5. Oh, because JavaScript is longs. Fine. I don't know how to do that, do I, in JavaScript? I don't. Let's see. Let's do this. Yeah, double % floating point. You'll have to write. Okay, integer math. That'd be slow or hard or both. Fine. Unsigned. What does this say? String values from bitwise operators must be 2-degree integers. Okay. You can just perform a binary that would have no effect. For the convert a float to an integer using a non-binary or. Got it. Okay, so good. This makes it even easier. So we don't need this x original anymore. We can simply check if ret val does not equal ret val with this binary operation will return 0. So if, even though it's parse int, it's going to give us a double float because that's how JavaScript runs. That's how it lives its life. We're going to say, alright, well, if the 32-bit integer of this one doesn't equal what you gave me, we're just going to return 0. And this should be able to check for overflows that way. Hopefully this works. Accepted. Wonderful. We did it. Alright, so we can see how we did. There's more than likely a few ways to improve this, but not bad for a first try here. Let's see. So we're a little slower We're considerably slower than the average. But that's okay. That's part of the learning process. So, thanks for watching this. I hope you all got something out of it. If you have any questions, feel free to leave them in the comments. I'll post this completed code down there if you all want to experiment with maybe ways to improve it. And I'll see you next time. Bye.